Okay, while we're getting okay, yeah, it has been yeah, we started already. Hi Kingsley, hi Kay, how are you doing? Happy weekend. You could unmute yourself and speak. Hi Kay, hi Kingsley, good evening, how are you doing?
Good evening. Good evening. I'm fine. Thank you.
Alright,
I'm fine. Good
alright.
evening.
How's the classes been for you?
It's been fine. I joined the last class, but I left halfway because of my partner. So it's been good.
Okay, you check the recording, Shay, Abby.
I've not checked the record. Serious. Oh,
But you check it, right?
yeah, I'll check it. I'll check it. I forgot.
Alright, okay. So we don't take too much time. Okay, Mr. Toby, you can start. Thank you so much. Thank you for your time and for your presence, sir. Thank you, sir.
Okay, good evening. Hello, everyone. Hello.
Yeah, good evening, sir.
So I want this class to be like the last class. So I want everyone to unmute their mics. So I want to be interactive, just like the way we did in the solidity class. So coming. To declare a variable in Rust. If you have to declare a variable in Rust, how do we do it? Anybody? Hello. Hello, everyone. Hello. Can you hear me?
Yes, sir. Yes, sir.
So I'm asking you guys to declare a variable for me in Rust. Like, if you have to declare a variable in Rust, how do we declare it? Nobody? K. Hello, K. Hello. Please respond. If you cannot answer the question, respond by saying I cannot. Instead of keeping mute.
Sir, my network is fluctuating. I'm not really getting you.
Okay, okay, sorry about that. Okay, I'm asking if I'm to declare a variable in Rust, how do I declare a variable? How do we declare variables in Rust? That's the question I'm asking. Yes.
Sir,
Yes.
Okay, the question on to declare a variable, can I answer? Sorry, I just entered. I don't know if it's a general question or it's just to one person.
No, it's a general question. You can answer.
Okay, we can use the let syntax to keyword to create a to declare a variable.
Okay. The left keyword. Okay. Go on.
What is the other part of the question, sir?
Just declare a variable. Like how do you declare it? You say you can use the let keyword. So how do you use the let keyword to declare a variable?
Okay, so yes, well, let's assume we want to declare a variable of let's say the variable is fruit, for example.
Okay.
So yes, fruit. So that means we are taking in a string. So
Okay.
we say the let keyword, the um then the name of the variable,
Okay.
then we find the type of the variable. So which is going to be a string.
So how
Then
do
it's
I
going to be
how
equals.
do I attach the type of the variable to the declaration?
We'll put a colon. I think it's called colon, right?
Okay. Okay, that's
After the variable name, we'll put a colon.
okay.
Then we'll put the type. Then
That,
we'll put equals to the value. Yes, sir.
that's correct. That's correct. Okay. Um, by default, what can you say about? So what can you say about Rust variables by default? Like if I declare a variable in Rust now, what's the default feature of a Rust variable?
They are
Yeah,
immutable, right?
the
What is it?
okay, yeah, they are immutable.
Immutable.
I said
Okay,
they
meaning that
Variables are
are,
immutable by
what is it? Hello?
I said they are
okay.
immutable.
Okay, they are immutable. That's correct. That's correct. So by default, Rust variables are immutable. And what does it mean when we say they are immutable? What do you mean by that? What do you mean by that?
They can't be changed. Like
Can be changed. Correct. So if I want to make a variable changeable or mutable, how do I do that? How do I do that in Rust?
you, yes, you use. I don't. I can't remember. Can't remember.
We will use the mut keyword before the variable. That means let's mut whatever the variable
Okay.
name is. Then it's
Okay.
immutable.
That's correct. Now, are you the only one in the class? What of the other people? Are they not? They're not in the last class, or I want this class to be, interactive. I want everybody to say something. Hey, hello, Mr. K. Are you
So,
with us?
so I'm with you. I'm with you. I answered one of the questions. Now with you.
Okay, which one did you answer?
When you said like Ross, I told you they are immutable.
Okay, you were the one that said they are immutable. Okay, I thought it was Craft. Okay, so use the mute keyword to make the variable what mutable. Okay, that's good. So, what are the data types that we have in Rust? What are the data types that we have?
Um, for Rust, we have
Yes,
actually they usually say we have two types.
we have
Actually, we
what?
have the scalar types, which under the
Okay,
scalar types we have the integers, the
okay,
floating point numbers, the boolean, and the
okay,
characters. And we have the compound types. Under the compound types, we have arrays and tuples.
okay. That's good. Mm, to print something out on the screen in Rust, how do you print something out on the screen in Rust?
You just use print,
Okay.
then
Uh,
ln, then the exclamation mark.
Okay,
Then we
what's it
put
called? The print ln exclamation mark. What's it
a
called?
print line macro. Print line macro.
Okay, it's called a macro. Okay, that's
Yes, sir.
good. So it's like a function, but it's different from a function. So continue,
Yes, sir.
continue, continue.
Then we then braces, then double quotes. But if you are
Okay,
to print a let's assume a variable, we need to use
okay,
this curly brace
okay.
as a placeholder. Then we put the name of the variable after the comma outside the double quote.
That is
You can also put the
that's
variable
perfect.
inside the braces too, inside. So
That's perfect. That's perfect. That's good. So you print things on the screen by using the print line macro. That's correct. Mm, for every Rust function, a serious function, every Rust program, there is always an entry point. What's the entry point called? Called What's the entry point of a Rust program?
Entry point. Please, can
Yes.
you? I don't know
Okay.
if
Point
that's
simply
the
means
word.
entry point simply means where the Rust program is going to start executing from. Are you getting it?
Okay,
So
for a
Entry,
function.
yeah, it's the function. Are you getting it? It's the function. So what's the name of the function? Where the execution is going to start from?
the main function now.
What do you call it?
Yeah. The main function. The main function is
Main
correct.
function. That's correct. That's correct. So it's called the main function. The main function is the entry point. So in your Rust program or your Rust programs, chances are you're going to have many functions. You may have tens of functions, thousands of functions, and so on and so forth. But then when the execution is about to start, it has to start from somewhere, and that's where the main function comes in. So the main function is the entry point of the Rust program or Rust application. Okay, on to the next question. Talked about ownership. Did you talk about ownership?
Ownership.
Yes. Okay, we have not talked about it. Okay,
I
maybe
think we
next
have
time.
talked. I think you just went over it briefly like that, Sha.
Okay, briefly. Okay, what did I say about ownership? What are the things I talked about ownership? I talked on ownership.
Um, you mentioned that is one of the things that makes Rust stands out. That's um
How does it make Rust stand out? And what are the problems that ownership is solving?
okay. Can we? Am I saying? What
What do you say?
I don't know. Can we see him?
Can you?
Can we see him?
I can hear you. I mean, what are you asking?
Okay.
I
Okay.
can hear
Okay,
you.
sir.
I can hear you clearly.
Okay, sir. Um. Yeah, I think the one of the problem in source is being able to to free memory. It makes it easy to
Okay.
free memory
Okay.
and
Free memory.
yes so which is one of the issues for other languages like C++, like you don't know when to free and when not to free. So sometimes there are some errors and problems that comes up as a sort of not knowing when to deallocate and allocate memories and all. So but Rust handles that with ownership. And
Okay. That's good. So the reason why we have ownership or the principle of ownership is because Rust is a compiled language. We talked about interpreted languages and compiled language. So Rust falls into the category of compiled language. And in compiled languages, you have to manage memory by yourself. You have to manually allocate memory. You also have to manually deallocate memory. Now, managing memory, which is a form of allocating and deallocating memory, can be a daunting task sometimes. There are times whereby you may forget to free a memory. There are times whereby you may free a memory. The memory that you have already free before, you may free it again. That's double pointer error. Are you getting it? There are also
yes,
times whereby there may not be space again. So managing memory is not that trivial. Are you getting it? In
yes, sir.
languages like C and C++, that's why you only see vulnerabilities in software written in C and C++ because of memory issues. I get in memory leaks, memory overflow, and so on and so forth. Do you understand? But
Yes, sir.
what Rust does is it enforces some certain rules in order for you to uh, in order for you not to fall into the pit or trap of memory leaks and double free error. So we talk more on ownership. Are you getting it? But
Yes,
basically, or in a nutshell, what ownership does what you have said. I get it.
Yes, sir.
So that's it. Okay, let's move on to the next thing. Um, did you talk about shadowing?
Yes, sir. We talked about shadowing.
Okay, what's shadowing?
It's basically redeclaring a variable with the same variable name. Like
Okay,
we
that's
declare with another name, yes, with the same name.
that's the
Yeah.
same thing. So that's correct. So
Yeah.
you can declare a variable twice in
Yes,
Rust.
yes.
That's unlikely. That's not possible in other languages. Language like JavaScript, even Solidity. Once you declare a variable, you cannot declare a variable twice. Although you can declare it in different scopes. I get it, but in the same scope, you can't have a variable twice. It's going to throw error. But Rust supports that kind of syntax or that kind of pattern. Do you
Yes, sir.
understand?
So
Okay. So, mm, did you talk about scope? Have you talked about scoping?
yes, sir. I think we mentioned that in the first class, though.
Okay.
I don't know. Yeah.
Okay. What do I say is scope? Is a scope.
Like a particular variable or so or function is only valid within its scope. For example, if a variable is declared globally, that means outside, and
Yes.
that same variable is used inside the scope, or yes, it's used inside the scope and given another value inside the scope. Inside that scope, that means I'm talking about a mutable variable now. Inside that
Okay.
scope, variable is that value that is given. But outside the scope, the variable will return back to its initial value, which is the one outside the scope. So I don't know how I can explain it with just mouth, but I think that's just the way it works. And we use the braces to to separate. That's how we know which one is inside which scope and which one is outside the scope. And the open curly and the open and closing curly braces. So we know which one is inside the scope and which one is outside the scope. So, but basically, the idea is that the value outside the scope can be used inside the scope, but the one inside the scope dies. Its lifetime is only within the scope. You know why? Outside the scope is no longer valid. So,
That's a brilliant explanation. I like that. That's very. I've said it all. So when we say scope simply means the part of a program where a variable is visible. So let me just put it like that: where a variable is visible. So the first scope or the topmost scope most of the time is the main function, main function block. So when you declare something inside the main function, the variable is going to be visible to every other function or every other sub-function or nested function inside the main function. I get it. But if you declare a
yes,
variable,
sir.
let's say inside the function, it is
Hello,
not going to
Itundo.
be. Hello, can you hear
Yes,
me? It's not going to be visible inside the
yes,
main
I'm fine.
function because it is scoped into that what function. And also, a variable is not only scoped in a function; it can also be scoped inside a loop. Are you getting it? Or even
Oh, yeah.
conditional statements. So if you have if-else statements and you declare a variable inside, you cannot access it outside of that if-else. So basically, anywhere you have curly braces, like you just said now, are you getting it? Anywhere you have curly braces, opening and curly braces, anything you declare inside um, opening and closing braces is scoped to that particular what section of the code. So it also helps us. Are you getting it? So that you don't have naming issues. Imagine you declare a variable called, let's say, H somewhere, maybe at the top scope. Let's say you now need something similar. Are you getting it? If
Yes, sir.
if there is no concept of scoping, it means that the one you are declaring inside the function is going to clash with the one inside the main function. You get what I'm trying to say?
Yes, sir.
So in order to prevent name clashes, that's why we have scope. Do you understand?
Yes, sir.
So thank you for that explanation.
Thanks, sir.
Okay. Mm, Did you talk about assignment operators? Did you talk about operators?
Operators.
Yes.
Yeah, assignment in what sense? Sir?
Okay. Did you
Assignment
talk
like
about compound assignments? Like if I have, let's say, norm, if I want to add one to norm, let's say I have the variable declared as norm,
plus equals to minus equals to.
plus equal to minus equal to.
Yeah.
So those are assignment operators. So how do they work? Can you explain how they work?
Yeah, it's just like a shorthand for example, if I want to add one to a norm now, instead of writing
Okay.
norm equals to norm plus one, I can just use
Okay.
the shorthand norm plus equals to one, still doing the same thing, just a shorthand.
That's correct. Okay, what do if I want to find? I want to find the remainder. Let's say I have norm one, and I want to find the remainder when you divide it by 5. How do I do it?
Um, I always use modulo.
Modulo. That's correct. So modulo is used for finding remainder.
Yes, sir.
Okay. What about what is the tax? Okay, how many types of string do we have? How many types of string do we have?
How many type of strings?
Yeah, string do we have
Uh,
in
I
Rust?
don't know, but it's only two. I'm only seeing Sha. That's the
Okay,
string slice and the normal.
just those ones I wanted to mention. So we have two types of strings: the normal
Two
string
and
slice and
string
the
slice.
normal and the other type of string. I get it. So
Yeah.
one is the both of them are reference types. You understand? They are reference
Yeah.
types. We talked about ownership. Are you getting it? Now,
Yes.
ownership will become handy or very handy when we start dealing with strings, string slides, arrays, vectors, and so on and so forth. You start seeing the power of ownership. You understand?
Yes, sir.
So we have the normal string, which is written as capital letter S, then the other ones lowercase, that string. Are you getting it? Then we have the string
Okay.
slice, where you use the ampersand str to declare
Yes, sir.
a string variable. So those are the two
Yes,
types
sir.
of strings that we have in Rust.
Uh,
Okay,
sorry, sir.
okay, go on.
Yeah, on these strings, like I think the capital one, the one we declare with capital string, then the main one small letters. I think they said that one stores its values on the heap. Why
Yeah, you thought if
the other one, the string slide
slice
STL.
on the stack.
Yeah, I think yes, they usually use it with reference, and I think it's like it's storing the reference to the
Yes,
string on the stack
yes.
also.
So basically in Rust, anywhere you see ampersand, we're talking about reference. Are you
Okay,
getting it? We're talking about reference. Can you hear me?
yes, sir.
Yes, sir.
Hello. So, okay, let me even talk about heap and stack. So, remember we said compiled languages like Rust, you have to do what? Manually demand for memories, if you want memory. And when
Yes,
you are
sir.
done with memories, you have to manually do what? Deallocate the memory. So,
Yes,
in the course of writing your program, once you compile your program, there are some memories that is known as compile time. We have two types of time. When I say time, I mean compile time and run time.
yes,
Do
sir.
you
Yes, sir.
understand? So when we say compile time simply means after writing your code, when you compile it, the state of your application, that's what we call the compile time. Are you getting it?
Yes, sir.
Now, when we're not talking about runtime simply means when your application start running, when the user start using your application, when you yourself start using your application, that's what runtime. Do you understand?
Yes, sir.
So at compile time, all the memories are you getting is that you declare, all the memories you declare are being stored in the in the stack at compile time. All the memories that are known, all the known memories are being stored in in the stack. But then there are some
Okay.
memories that you can't really guess how many memory that you need. For instance, if you want to store, let's say, a string now, you don't know the length of a string. You
Yes,
don't
sir.
know the length of the string that you want to store. Are you getting it? Are you getting it? So
Yes,
you
sir.
cannot store that. You cannot save that ahead on the on the stack.
Yes,
So that's
sir.
where the heaps or the heap rather comes into picture. So the heap is used for storing things that are dynamic, that are not static, things that can grow. Are you getting it?
Yes, sir.
So anytime you now want to reference something from the heap, you mostly use ampersand. Are you getting it? So
Yes,
it's called like a pointer. It's just like a pointer. Have you heard of pointer before?
yes, sir. In C
Yes.
and C++.
So it's yeah. So it's called a pointer. So what we mean by a pointer is that it points to the address, not to the value. Point to the what? Address of
Yes,
another variable, not to the what? To the value. So it's called the pointer variable. Do you understand? So most times
yes,
when you see ampersand in Rust, you're accessing maybe an address. Are you getting it? Or a reference type? Do you understand?
yes, sir.
So we talk more on that too.
Okay, sir.
Okay. Mm, have you used the conditional statement before? Like in the course of
Yes.
our class? Okay.
Yes, sir.
Yes, we did.
What conditional statement we use?
If
If, okay. If and what?
We also have the we also have the while loop. We have the normal loop. We have the for loop. Also conditional.
Okay. Okay, they're actually different. Are you getting it? So we have conditional statements. The other ones you mentioned are called iterative statements. Are you getting it?
Oh, okay.
Do you understand? So we have
So if
conditionals. Conditionals
as
are used for making decisions for branching. So if this is not true, do this. If this is true, do this. That's what conditionals are. So loops are used for iterating. So if you have, let's say, a list of, let's say, 10 numbers or an array of 10 numbers, and you want to work on each of them, a naive approach, are you getting it, is you start calculating everything one by one. Calculate the first one, calculate the second one, calculate. With that, you're going to take a whole lot of space. So imagine that the number of items now increase to, let's say, 1,000. Are you going to be doing all those things for 1,000 items? That's not practical. Do you understand? So that's where loops come into picture. So loops helps you to do what? Work on list of things. Sometimes it's not even list of things or list of items. Sometimes it could be that you want a certain condition to be false, or you want a certain code to be running until a particular condition is false. Are you getting it?
yes, sir.
So that's also another use case of loops. So we have the normal loop, the one that is LOOP
Yes, sir.
is is an infinite loop. Hope you know.
Yes, yes, sir.
So it's infinite loop. What do you mean by infinite?
You just keep going on
What do you say?
forever as long as, but you can stop it with the break keyword.
Yes, it keeps on running forever. If you don't stop it, to continue running. Sure you get. So the other type of loop are not infinite. The for loop, that one is not infinite. Now, apart from the if else statement for conditional, we also have another form of conditional statements.
Oh, is he match?
Yes, yes, that's it. So match. So match also helps in what? Decision making. Now, you can think of match as the the equivalence of switch in
Yeah,
JavaScript
yeah. We also
in
use switch
language like
in
that.
Python
What
too.
is it?
Yeah, we also use switch in Python.
Okay, switch in Python. Oh,
Yeah.
so you can think of match as the switch in Python or switch in JavaScript. They are the same thing. I getting they perform it, but they do the same thing. I getting, but then there are some, how would I put it? You know, in every language they have the same features, but then there are some, little things that differentiates this particular language from this particular language. So they're actually the same thing. So match and the same thing. Okay. In a match statement, what how do I put how do I state the default case? Default case.
Default case
How do I state it?
for match.
Yes.
Okay. So can I use mouth to say? Okay,
Wait, you
let's
know what I
assume
mean
one
by default case? Do you know what I mean by default case?
default state. I don't know.
Case. Okay, this is what I mean. This is what I mean. If you have an if else statement, are you getting it? If you have
Yes,
if statements, if else if else if else if. Now the
yes.
default case for if statement is the else. Else simply means if every other if else did not run, if the conditions are not met, then you should do what? Fall back to what? Else. That's what it means. Do you understand?
Okay.
So the same thing applies for match also. So if you check match, the first there are different arms in the match statements. So if the first arm is not, if the condition of the first arm is not met, the second one is going to be what? Tested. If that one is not met, the third one. Now, if all of them is not met, what will happen? It will go to the default case rather, or the default arm. So how do I state that default arm? That's what I'm asking.
Man, I don't even know. I don't know what I don't understand how you want to answer it, but I understand how match works, yeah. Except if you
Oh,
want to use the error handling way of using some and
no, I'm not even
some,
talking about that.
but I don't understand what you're trying to say. But I understand how it works.
Okay, you know how switch case work?
How what's that?
Switch case,
Yes,
switch.
sir.
You know how it works?
Yes, sir.
Okay, if you have a switch case, if all the case, if the condition of all the cases are not met, what will happen? What will happen?
So four boxes. Sir.
What is it? Hello?
Sir?
I say in a switch case statement, if all the conditions of the cases are not met, what will happen to that switch case? What will the switch case do?
There's always default.
There's always default. So my question now is that what's the equivalent default in March? How do you state the default in March in the March statement?
Okay. I think we use this. Sorry, I don't know if I'm correct, Xiao, but
Okay.
let me try. I think we use this dash sign then equals to and greater than sign to me any other thing, any other case, any other thing.
Okay, you
Then we
tried, but it's actually underscore, not dash.
here underscore equals to then greater than
Yes.
the mean
So you
any
use
other.
the underscore. You
Yes,
understand?
yes.
Okay, let's talk about declaring variables. Let's talk about identifiers and all that. So how do we
Okay.
declare? Okay, we should talk about how to declare a variable already. So what are the
Yes, sir.
rules for naming things in Rust?
Yeah, we use snake case.
No, I'm talking about naming, like identifier.
Okay, identifier.
Like if I want to declare a variable now, how am I going to name my variable?
Name it. I
Yes.
don't understand.
Okay, if I
Oh,
want to
name it.
declare a variable now. Let's say I want to declare a variable and I call it name. I've declared the variable name.
Yes,
Are we? Okay,
yes.
if I declare a variable now and I call the name of the variable, let's say let's, what will happen?
It's not work because let's say the
Yeah, so
say
that's
it
what I
name.
wanted. That's
Oh,
what I want to tell me. So apart from declaring a variable that way, which other way am I going to declare a variable that will not work?
okay. I think we cannot use number to as a variable value. I think that's
Okay.
one. A
Are
bit
you sure?
as a variable name. Can we
Are you
use?
sure?
I don't know. I'm just asking.
Okay. Okay, actually you can use the number, but the
Uh,
thing is not start with a number. You can't start with a number, but we can use a number. Do you
oh,
understand? So I cannot have let's say one name. That would be wrong. But if I do
Yeah,
name,
yeah.
that would be right. You understand?
Yes, sir.
Okay, what are that rule?
I did not learn it. I don't know. Sir, can you please just say it? I
Okay,
don't know if there's anything you want to hear. I don't know.
okay. You cannot have special characters also in your identifier name. Like
Oh,
you can't have hyphen, you can't have question mark, full stop, colon, semicolon, your identifier name. You remember?
yes, sir, yes, sir, yes, sir.
Okay. Also, um, Rust is case sensitive.
Yes, sir, yes, sir.
So back to the first rule. What was the first rule you told me about? Like I cannot use letter B.
Yes, sir.
So what if I write my letter in capital letter? Is it going to work?
Yeah, it's going to work
Why will it work?
because the 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 one being used by Rust is in small letter. So
So that's correct. So Rust is case sensitive. So anywhere
yes,
Rust is using small letter, if you decide to use capital letter as your one identifier name, it is
yes,
not
sir.
going to be error for you because capital letter let is not recognized by what the Rust compiler.
Yes, sir.
You understand? But is that a good practice? Is
No,
it
no,
good
no.
to do that kind of thing? It's not a good practice. Why? Because it's going to confuse you. Number one, it's going to make your code hard to read, and other people will not be able to, collaborate with you properly. Are you getting it? That's not
Yes, sir.
the right way. That's not a good way to write code.
Yes, sir.
Okay. Mm, did you talk about the different, variants of integers?
Yes, 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 yes.
Okay. What did you say about the different variants?
We have the. Sorry, is there another person that wants to talk?
K. Hello, Mr. K.
Yes, sir. I'm here, sir.
Okay. What are the different variants of integers that we talked about?
I have no idea. I have no idea, sir.
Okay.
Okay, sir. Can I talk
Hello.
now, sir?
What is it?
Sir, can I talk now, sir?
Yes, you can. You can.
We have the for integers, we have the signed integers and the unsigned integers.
Okay.
So for the signed integers, I think we have from even as small as I8 to like I2128 or so. So I or U, I is used for the signed integer, that means negative or positive. While U is used for the unsigned integer, so that's only positive numbers. And I think we have from U8 to U128. I think 128 is the highest. That's 128 from 8 to 128. That means 8, 62, 64, and that's 128.
That's correct. So we have from we have 8, we have 16, we have 32, and so on and so forth. So what makes them different is that each of them they have a limit. They have what they can accept. For instance, I8 now you cannot assign a number that is greater than 127 to it. It's not going to work. It's going to throw error to the for you. The same thing, you cannot assign a number that is less than I think 128 or 126. It's also going to throw error. You understand? So the
Yes,
same
sir.
applies to I16. There's a range of value that I think there's a formula for that from negative 2 raised to the power of n minus 1
Yes, sir.
to 2 raised to the power of n minus 1 minus 1. Do you know the
Okay.
formula?
2 is by minus 1, Abby.
Yes.
For,
That's
okay.
for that's for IU. Then for
Okay.
unsigned, there's a formula for unsigned too. So you
Yeah.
can check it out.
Okay,
So
sir.
It's going to give you the range of the numbers that you can represent. I get it. Actually, what happens is that those numbers are represented in bits behind the scenes. They're represented in bits. So if you
Yes,
use 8 bits, if you use 8 bits,
yes,
it's
sir.
going to it's going to it's going to use if you use the I8 rather, it's going to use 8 bits. I get it to represent it. 8 bits
Yes,
to
sir.
represent. If you use the I16, you're going to use 16 bits to represent it. So there are things that go on behind the scene, but then that's not part of that's beyond the scope of what we are doing.
Okay, sir.
Mm, okay, what about declaring a decimal number, a number that has points? What type do we use?
We use the floats. And I think there are two major ones. We use F32, S is F64. F is
Oh,
for floating point numbers. But I think
so
most time
that's
people use F64, sir.
what do you say? Most times we use
F64, I don't know why, but I usually say F64 most times. I don't know why
okay.
people.
The thing
Yeah.
is 32 is 64 is more precise than 32. It's
Yes,
more
sir.
precise. When we say precise, it simply means that it can accept more decimal place. Do you understand?
Oh,
So if you're making
okay.
a calculation now and you have, let's say, and it's giving you, let's say, 14 decimal place, if you store it
Yes,
inside F32, it's going to approximate it for you and truncate anything after this decimal place because it cannot accept more than, I think, 7 decimal places. But F64 can accept up to 14 decimal places. Do you
okay,
understand?
sir. Yes, sir.
So that's why most times they use 64. But if you know that your calculation is not going to exceed 7 decimal places, then there's no point using 64. Just go with 32, F32. So it
Okay,
all depends on the type of calculation you are making. Are you getting
okay.
it?
Yes,
And
sir.
the amount of precision that you need in your application.
Okay, sir.
So mm, I think we should wrap up the class for today.
I,
So,
I have a question, sir.
okay, what's the question?
There's this thing that has been giving me, that has been bothering me, and that is the fact that since they said writing Rust programs, it's easy to write safe programs, right?
Is what?
Program that it's easy to write safe programs in Rust, or Rust makes it mandatory for you to write your programs properly.
Yes,
So
yes.
now, then, what is the work of auditors actually? Like, what is their
What's the
work?
work of what?
Auditors, because like
Auditors.
auditors,
Azar.
blockchain security engineers, and they're looking for vulnerability. What are they really looking for? If you can,
Okay, okay. Oh, I
yeah,
get your question.
if they
Are you
can,
talking about
if you
the
can,
testers?
sir,
Are you talking about the testers? Are we?
yeah, like blockchain security engineers, the
Okay, okay,
security engineers. Like since for Solana now, I know they have seen several blockchain security engineers, and I think they call them auditors sometimes. Yeah.
okay.
And they said they are doing auditing contests, this one, this one. Like since you can easily write a safe program in Rust and like everything without vulnerability, then that means it's very difficult to find something wrong with the programs and be able to
Okay,
like so
that's a good question.
yeah, they look for. Yeah.
That's a good question. So first of all, no matter how you try to write a program, the program cannot be 100% secured or 100% safe. Are you getting it? There are
Yes,
still
sir.
there's still be some loopholes. Even the best, even organization with the best programmers, best hackers, they are still hacking them. People like Binance now.
Yes, sir.
Binance.
Yes, sir.
As good as they are, as popular as they are, they still hack them. Even NASA, even Pentagon, they still hack them. So you get
Okay.
so the safety. When we talk about safety, about Rust. It's just the compile time. Are you getting it? So
Oh,
what
okay.
what what Rust does is that it helps you to detect every form of compile time error, every form of compile time error that may affect your program when it is running. Are you getting it? That's
Yes,
what
sir.
Rust does for you. But then while your program is running, it cannot do it. The Rust compiler cannot do anything because the program is already is already compiled. Now, apart from compilation error, there are also some other forms of error that you may introduce into your application without you knowing. We also have logical errors. Are you getting it?
Oh, yes, sir.
Logical error simply means that your code is going to run perfectly. Are you getting it? But you as a
Yes,
programmer, you might have messed up some things. For instance, we are supposed to do +1. Maybe you write +2. Are you getting it?
yes, sir.
So that one, that one that you're adding to it, that SS1 is a logical error. So those are the
Yes,
things that they test for. It's not just about the syntax errors. It's not just about the compile time errors. There are also logical errors. So you have to test for logical errors. That's
okay.
fix of the programmer. Also runtime errors. So you also have to test how the Rust application is going to run. We have different
Mm,
platforms. We have Windows, we have Linux, we have Mac. Are you getting it? So how a Rust program will run on Windows may be different from how it is going to run on, let's say, iOS. So what you do is kind of write code that adapts different operating system. So that's another reason why they do what they audit. Are you getting it? So it's not mainly
yes,
for compile. Even the compile error, everything cannot be caught or cannot be detected by Rust. Not everything can be detected by Rust. Do you understand?
yes, sir.
So that's it. I hope that answers your question.
Yes, sir. Last question, sir. Sorry.
Okay.
I was reading about pointers and references, and they said Rust also allows pointers, but only when you're writing on save Rust. So my question is, what is the essence of save Rust? Why are we, if Rust is making everything safe for us, why are we now writing on save Rust again? What is the use?
Okay. I like that question, Sha. And the thing is, sometimes, developers, okay, let me just put it this way. Languages like Rust, they kind of restrict developers. Are you getting it? They force you to write in a particular way. Like, you must write in this particular way. If you don't write in this particular way, the programming language or the Rust program is not going to compile. Now, there are times whereby programmers want to,
Yes, sir.
have control of everything. Are you getting it? As a programmer, there are times whereby you want to have control of everything you are doing. You don't want any restriction from any compiler. I get it. That's where
Yes,
you know features like that come into handy. Do you understand? Hello.
yes, sir.
Now, do
I
you
can
know
hear
of
you, sir. I can
TypeScript?
hear you, sir.
Have you heard of TypeScript before?
Yes, sir.
Hello.
I'm
Have you
presently
heard of
learning
TypeScript?
TypeScript, sir.
Okay. You know TypeScript, you know JavaScript. Have you?
Sir?
You know about JavaScript too. Do you know about JavaScript? Have you heard of JavaScript too before?
Yes, yes. I
Okay.
can program in TypeScript also.
Okay. Now, if you're writing JavaScript, you have a lot of flexibility. You can do anything you like. Okay, Hello.
I can hear you
Hello.
now, sir.
I say with JavaScript, you can do everything, any kind
No,
of thing
sir.
you want with JavaScript. But then with TypeScript, it is not possible for you to do what? To do everything. You are restricted. If you declare a variable in TypeScript and you don't
Yes,
use
sir.
it, the TypeScript compiler is going to yell at you that no, you have to either use this variable or get rid of this variable. If you type something as string and you're passing in a number, TypeScript is going to yell at you. It's not going to compile. Are you getting it? So those kind of things
Yes.
that can frustrate programmers sometimes. So there are times whereby you don't want those kind of errors or those kind of restrictions in your program, and that's the
Yes,
unsafe
sir.
comes in. Do you understand?
Okay. Okay.
Yeah, I'm trying to say.
Okay, sir. Yes, sir. I understand, sir.
Okay.
Sir,
Yes,
please, I
thank
have a
you.
question. It's not
Okay.
related to. So, like, I wanted
Okay.
to ask, like, programming in Rust, because I'm actually new to Rust and everything. Like, are there any prior knowledge someone needs to have? Because I've been following the class, and I remember last time I asked you about how we can install the compiler, so I can we at least practice that. Are there like any prior knowledge somebody need to have like before he can get more proficient?
And there's no really crowd knowledge, but then if you have understanding of another programming language, it's going to help you. Are you getting it? It's going to increase your, you know, learning speed. And even without having any prior knowledge of another programming language, you can still learn Rust. Are you getting it?
Because
Learning Rust
I
is
because I mean,
okay.
this one- excuse me, because this one I asked like some people are like Rust is very hard to learn something, but I just said like I will learn it and
Yes, yes. Rust is very, it's not that beginner friendly. Do you understand? It's not that beginner friendly. But then it's something you can do. Okay, guys. If you have knowledge of a programming language before, it's going to help you. It's going to, it's going to increase your learning speed. But then even without that, you can still learn it. Do you understand?
okay, okay, sir.
Any other question?
No, sir.
No, no,
Hmm?
sir. No, sir.
So we see next week. Next week we continue writing our codes.
Okay, sir.
Like, is there so I the last class we did, you said you show us stuff to install because me, I basically don't know what I'm installing on my system at least so that I can be trying out.
And for now, when it's time for us to install, we install. For now, we keep on using the online this thing, online compiler.
So you didn't drop you said you dropped the link for us. You didn't drop it last
The
time.
link. I didn't
Yeah.
drop it. I thought I did. Okay, I will drop it maybe in the next class. Or before.
Alright,
I'll drop it. I'll drop it.
no problem.
Okay.
All right.
Okay. Bye.
Thank you, sir.
Good night, everyone.
Thank
Thank
you,
you
You're
so
sir.
much.
welcome. You're
Yeah,
welcome.
thank you, sir.
Bye, sir.
Bye.
Thank you, ma.
Thank you, man, for this.
Thank you very much, ma.
All right, boss. Take care. Good night. Good night. Yeah.
Yeah, good night, boss.